Imagine working on an idea for over 30 years while the world told you it was impossible. Until one day, it reshapes the future. That's the story of Geoffrey Hinton, a man who pioneered deep learning and neural networks, revolutionizing artificial intelligence. And now, he's raising serious alarms about the very technology he helped create. Geoffrey Hinton is a name deeply tied to artificial intelligence, and rightfully so. The impact of his work is everywhere. From voice assistants like Siri and Alexa, to self-driving cars, photo recognition on Google, and the very powerhouse AI system behind ChatGPT. But Hinton's story is more than just a tale of success. It's also a story of persistence, belief, and ultimately, a cautionary tale about AI's future risks. Today, we'll take a closer look at the fascinating journey of Hinton's career, starting from his early fixation on how the brain works to his pioneering breakthroughs in neural networks, and finally, to his resignation from Google in 2023, where he sounded a stark warning about the dangers ahead. Buckle up. This is the real story of artificial intelligence. First, let me take you back to the early days of AI. It's the 1960s. The world is being introduced to ideas ranging from space exploration to the promise of a computer age. Meanwhile, a young Geoffrey Hinton is grappling with a transformative realization. Picture this. Hinton is a high school student when he has a conversation with a friend that changes his perspective entirely. His friend suggests that the brain could work like a hologram, where memories aren't stored in one precise place, but instead in distributed patterns, spread across networks of neurons. This means that, just like a hologram, the brain could store pieces of memories across different regions, allowing for more complex interwoven forms of storage and analysis. At first glance, this might seem like an abstract, almost sci-fi concept. After all, comparing a brain to a hologram? It sounds far out. But for Hinton, this idea was groundbreaking. It planted the seed that would ultimately drive his lifelong pursuit to understand and replicate how the brain functions, not through conventional rules of computing, but via systems that mimic human neurons. Fast forward a few years. As he studied at Cambridge and later pursued a PhD in artificial intelligence at the University of Edinburgh, Hinton couldn't shake the idea that the brain's neural networks held the key to making computers think. But there was a gigantic, looming problem. Everyone around him in the AI field was looking for shortcuts. Rather than building systems that replicated the complexity of the brain, they were focused on developing machines that could handle cognitive tasks through simpler and more accessible methods. For most computer scientists in the late 20th century, artificial intelligence was a collection of hard-coded rules. If this, then do that. It worked, but only for narrow, specific tasks. In their eyes, creating an AI that could actually learn, not through explicit coding, but through mimicking how the brain learned, was too ambitious. And Hinton's warning to them? You're missing the real point. The journey wouldn't be easy. The big question? How do you make computers learning machines that mimic the brain? How could they absorb information and make decisions without being restricted to pre-programmed rules? But there was one key concept Hinton knew would be central to this journey: neural networks. In the 1980s, Hinton took the plunge into exploring neural networks with some of the most brilliant minds of the time. Working with collaborators like David Rumelhart and Ronald J. Williams, Hinton helped change the game for AI, all through a deceptively simple but incredibly powerful idea: backpropagation. Okay, let's break it down. What exactly is backpropagation? In its simplest form, backpropagation is a method by which neural networks learn from their mistakes. It's like a correction technique. Think of a neural network as a huge set of interconnected nodes, mimicking the neurons in the human brain, that pass signals to one another. These nodes are arranged in layers, each one computing different things as data moves down the layers. If the neural network makes an incorrect guess, let's say you're training a network to recognize a photo of a cat, but it mistakenly thinks it's a dog, backpropagation runs through the network in reverse. It tweaks the strength of the connections between nodes to gently nudge the system toward the right answer the next time. Here's how Hinton puts it. It's like adjusting many tiny knobs to improve performance. One tweak here, another there, and eventually the network becomes really good at the task it's given. The genius of backpropagation is that it allows neural networks to self-improve. even with the noise and countless variables they encounter in messy, real-world data. But there's one crucial thing you need to understand. Hinton and his collaborators at this point were working in the wilderness. The broader AI community wasn't exactly thrilled with neural networks. Why? Because at the time, the hardware needed to make backpropagation work just wasn't up to the task. Yes, the concept was brilliant, but the sheer volume of data and number of calculations required to train these networks were far beyond computers' capabilities in the 80s. So, while many researchers across the AI field were exploring other techniques, machine learning methods like decision trees, support vector machines, and rule-based systems, Hinton stuck with his conviction, despite the lack of belief from the larger research community. It's crucial to understand that this was a time when deep learning was seen as something of a fringe idea. For 3 decades, Hinton largely operated on the outskirts of the AI world, pushing neural networks ahead incrementally, while facing a lot of skepticism. By the late 90s and early 2000s, things started to change. Computers had gotten more powerful. Processing power was increasing rapidly, and most importantly, data, a lot more data, was becoming available. This was the time when companies like Google and Facebook began to realize the potential goldmine that huge data sets could unlock. And this is where the flashpoint of AI took place. Hinton was working with students at the University of Toronto and fine-tuning neural networks for specific applications, such as image recognition. Still, major breakthroughs in AI were isolated. The world was yet to see the kinds of jaw-dropping capabilities we see today with AI. The AlexNet breakthrough. Enter 2012, the year everything changed. Hinton, along with 2 of his graduate students, Alex Krzyzewski and Ilya Sutskever, developed a neural network model that set the AI world on fire. This model was known as AlexNet, and it was created to compete in the ImageNet Challenge, an international AI competition where teams race to create the best image recognition software. ImageNet is a huge data set composed of millions of pictures. The goal for AI researchers? To build models that could correctly identify objects within those images with as much accuracy as possible. What's incredible is that not only did AlexNet win the 2012 ImageNet competition, but it crushed the competition. AlexNet achieved a whopping 40% improvement over the second most accurate model. That's like landing on another planet in terms of a technical leap. Remember, we're talking about a moment where AI went from just acceptable to stunningly good. AlexNet worked by leveraging 8 layers of artificial neurons that processed raw pixel values of an image. The real magic, though, was that AlexNet didn't need to be told exactly what to look for. Instead, it could learn from patterns and discover differentiators between objects on its own. So, the model trains on the data, gets better with each pass of backpropagation, and refines its image classification capabilities with every iteration. This wasn't just a win for Geoffrey Hinton and his students, it was a watershed moment for the entire field. Suddenly, AI wasn't just a theoretical field. It was a commercial powerhouse. Startups, tech giants, and industries from every sector realized that AI could be applied to anything. Healthcare, voice recognition, natural language processing, music recommendations, driving cars, policing, agriculture, you name it. At this point, big tech came calling. Google snapped up Hinton's company, DNN Research, for $44 million after the ImageNet victory. With this acquisition, Hinton officially became part of Google Brain, Google's AI research group, where he worked part-time while continuing his teaching and research at the University of Toronto. Google's goal was clear: accelerate the development of neural networks and deep learning to improve search, voice, and image recognition, and to roll out AI-based services at incredible scale. But Google wasn't alone. In the years following AlexNet, Microsoft, Facebook, and Baidu, one of China's largest internet companies, jumped into the deep learning space. Every major tech firm was racing to increase its AI capabilities, scrambling to replicate the stunning success of AlexNet to explore its own AI-driven applications. And it wasn't just about internet services. Deep learning was creeping into everything, from email spam filters to self-driving cars to real-time translation apps. The bigger impact: deep learning goes mainstream. But why did deep learning suddenly explode in popularity in the early 2010s? Well, that's where big data and computational power come in. Neural networks only shine when they have a ton of data. Deep learning thrives on huge data sets. The more data you feed into a neural network, the smarter it gets. That's why neural networks didn't take off back in the 80s or 90s. We didn't have enough data to feed these systems, and computing processors weren't fast or powerful enough to churn through the millions, today billions or even trillions, of parameters and connections that these networks rely on. But in the 2010s, everything aligned perfectly. We had enormous amounts of data, especially labeled data, now thanks to databases like ImageNet, plus what was being generated online daily, and extremely powerful GPUs, graphics processing units. They were designed for gaming, but they turned out to be fantastic at churning through the mathematical computations that neural networks rely on. Deep learning became not just a frontier of computer science, but the dominant paradigm. Geoffrey Hinton wasn't just a researcher on the fringes anymore. He was now regarded as one of the most important figures in AI, considered by many the godfather of modern AI. And Hinton's work wasn't just reshaping image classification or machine learning competitions. His techniques and the advancements that followed became fundamental to some of the most sophisticated systems we use today. Ever used Google Photos? That assistant suggesting albums based on recognized faces? That's neural networks at work. Ever asked Alexa to play a song or asked Siri a question? They succeed by leveraging Hinton's work in voice recognition and natural language processing. Or tried talking to a customer service chatbot that actually seems smart? Yep. All of that traces back to deep learning and neural networks. Basically, modern AI systems driven by neural networks are creating new ways to process language, look at images, navigate cars, offer recommendations, and handle an incredible range of activities that were previously considered too complex or too ambiguous for machines. And the efficiency these systems brought became visible fast. With deep learning algorithms, tech companies have been able to offer AI at near unthinkable speed and scale. AI went mainstream, getting embedded into our everyday devices and platforms without us even realizing it. Yet Hinton, the man who largely made it possible, started to get very worried. The final twist: AI risks and Hinton's departure. In 2023, in a surprising move, Geoffrey Hinton announced his resignation from Google, leaving behind his decades-spanning role as a leading figure in artificial intelligence. When someone who has spent their life pushing the boundaries of AI decides to step away and express doubts about the very things they've created, it's time to sit up and listen. As AI became more ubiquitous, Hinton started asking some deeply uncomfortable questions. Not just about what artificial intelligence is capable of right now, but what might come next. Talking to news outlets in 2023, Hinton voiced concerns about the rapid advances in AI, particularly warning that machines were evolving far faster than humans could fully comprehend. ChatGPT, Bard, GPT-4, DALL-E, and other models had started to amaze. But Hinton's apprehension wasn't about their current abilities. It was about a future where artificial general intelligence, AGI, becomes real. Let's unpack this a bit. Narrow AI, which we have today, is designed for specific tasks, like recognizing faces, reviewing legal documents, or generating text responses. But AGI is the holy grail of AI. It would be a system that could handle any intellectual task driven by human general intelligence. We're talking about a machine that'll not only create, translate, and talk like a human, but think like one, perhaps better. And while Hinton, like many researchers, believed AGI was still decades away, signs are showing that the rapid advances in AI systems may shorten that timeline drastically. Hinton voiced several fears. 1. Autonomous systems control. As AI becomes more capable of improving and evolving without human intervention, the worry is that we may not be able to control its development. AI might get good at self-improvement in ways we haven't prepared for. And that's where things can quickly spiral out of control. Imagine AI creating new goals or objectives that aren't aligned with human ethics or welfare. 2. Technological unemployment. Initially, Hinton was optimistic that AI would automate the tedious tasks in industries, leaving humans to focus on more creative and meaningful work. But as AI began to accelerate in its abilities, this outlook changed. Hinton became convinced that AI might eliminate more jobs than it creates, and the world wasn't ready to handle this level of disruption. In essence, AI might increase inequality and make the rich richer, while leaving everyone else behind in a race they can't win. 3. Weaponization of AI. One of the darkest concerns Hinton highlighted in his interviews was the use of AI for malicious purposes. Autonomous weapons, for example, could be created without human oversight, allowing machines to make kill decisions independently. Or AI could be manipulated into launching full-scale disinformation campaigns, using deepfakes and fake news to trick people en masse. 4. Fake content. As AI has become adept at creating hyper-realistic textual, audio, and visual content, just look at deepfake videos, the fear is that AI could fundamentally disrupt society's trust in information. In the future, you might not know if the content you're consuming is real or created by a machine. That makes it incredibly hard to distinguish truth from lies, especially in a digital world dominated by automated phony content. 5. Existential risk. But arguably the most chilling of all Hinton's concerns was the existential threat AI might pose. In an interview after his departure from Google, Hinton said it's not inconceivable that AI could, at some point in the future, become powerful enough to wipe out humanity. Now don't get me wrong, that's not happening with ChatGPT tomorrow, but it's a future AI researchers need to account for. What happens when AI logic and human goals are no longer aligned? If you're starting to think this sounds a lot like a dystopian sci-fi plot, you're not alone. But these concerns have moved from books to real-world debates, with Hinton advocating for better AI governance, stricter guidelines, and international cooperation to prevent the misuse and unchecked rise of AI systems. To be clear, Hinton isn't anti-AI. He believes in the power and beauty of deep learning. The systems he helped build continue to drive innovation, cure diseases, and make daily life easier for countless people worldwide. But he also knows that power without control can be dangerous, and that's why he chose to publicly start speaking about AI risks. So where does that leave us? Geoffrey Hinton's contributions to artificial intelligence cannot be overstated. Through his work on neural networks, backpropagation, and deep learning, Hinton laid the foundation for some of today's most advanced AI systems. If you've interacted with AI in any form, whether it's asking Alexa to play a song, using ChatGPT to generate an email, or relying on Google to find the perfect photo, you've benefited from Hinton's groundbreaking work. The AI industry wouldn't be where it is today without him. Hinton helped turn an early, misunderstood concept into tools that are changing the world, often for the better. But now, as AI is racing ahead at breakneck speed, we have to ask new questions. Are we moving too fast? Can we control the systems we've built? And most importantly, are we prepared for a world where machines push us into unprecedented ethical and existential dilemmas? Only time will tell. Thanks for sticking around. Drop your thoughts in the comments below. For more great content, check out the video popping up on your screen right now, or check the link in the description.